Welcome to Study Loop.
Let's evaluate the following integral. We should go ahead and check to see if this denominator, this quadratic term, will factor before we do partial fraction decomposition. So here we look at the discriminant, b squared minus 4ac. In our case, that's just negative 4 squared, then minus 4 times 1 times 6. Now this is a negative number. That means that the quadratic is irreducible. It will not factor. So using what the book calls case 4, our partial fraction decomposition should be of this following form. And then we have another linear factor, cx plus d. And then this time we have the same factor, but we'll square it. All right, again, that's case 4. Then let's go ahead and multiply both sides of this equation by the denominator on the left. When we do that, and on the right, we have ax plus b. And then we have times the quadratic. And then just cx plus d. We can go ahead and expand that right side as much as we can. Bx squared and then combining, depending on the power of x, for example, we could pull out x cubed. We just have a. So let me rewrite this. And then pull out an x squared, b minus 4a. Pull out an x, and we have 6a minus 4b plus c. And then the constant term left over is 6b plus d. And there's parentheses around that. So now we look at the coefficient on the left and on the right. On the left, notice that there's no x cubed here. This must mean that a is 0. So then we also have b minus 4a. That must equal 1. So since a is 0, we get b is 1. So these are two of our values. Now let's plug these in for a and b are here. And if we look at the left-hand side, this should be equal to negative 3. So we have negative 3 is 6a minus 4b plus c. Now go ahead and solve that for c. We get c equals 1. And finally, let's solve for d. 6b plus d. That's the constant term on the right. That must equal 7. The constant term on the left. And then go ahead and solve that for d to get d equals 1. So now we have our 4 values, a, b, c, and d. Let's go ahead and plug these in to the constants up here, and then we'll take the integral of the right-hand side. Let's go to the next page. So plugging in our values for a, b, c, and d. So this is our integral. So let's go ahead and maybe let's split this into 2 parts. Let's call this a and b. So let's get a first. The first thing we should do for either of these integrals is complete the square. So let's look at that quadratic. We can go ahead and complete the square here, and we'll end up with x minus 2 squared plus 2. So let's look at part a first. We have dx up top, x minus 2 squared, and then I could write this as square root of 2 squared. That'll make my choice for the trig more obvious. X minus 2 is root 2 tan theta. Therefore dx square root 2 secant squared theta d theta. Now let's go ahead and plug these in. Root 2 secant squared theta d theta. So we're replacing dx using this. On the bottom, we have x minus 2 squared. So that will be this thing over here squared. So that's 2 tangent squared theta. And then root 2 squared is also 2. And instead of writing that 2 there, let me just put a 1 here, and then I'll factor out that 2 in the front. Now recall tan squared plus 1 is equal to secant squared, so we could cross those off. We have root 2 over 2. And then the secants canceled, we just have integral d theta. That's just theta. And we could go ahead and solve for theta by using the trig sub. So this, we could rewrite this as tangent equals x minus 2 over square root. Then solve for theta by taking arctan on both sides. So plugging that in for theta. And let me not worry about the constant c because I still have to deal with this other integral b. I'll add in the c at the very end. And then we have x minus 2, radical 2. So that takes care of our first integral a. Let's go ahead and start on the next integral, part b. So for b, and recall we completed the square on the previous page. And then the denominator this time had a square on the outside. So this is our integral. Using the same trig sub that we just used. Let me rewrite that. We'll go ahead and do the same trig sub as before. So we have radical 2 secant squared d theta. Now, we should also be careful in the numerator there. We have an x plus 1. So how do we get x plus 1 from this equation over here? You just add 3 to both sides. So if we add 3, the left becomes x plus 1, and the right-hand side, plus 3. So we can replace x plus 1 with the right-hand side over here. Root 2 tan theta, plus 3. Then we multiply by dx, and that's over here. Root 2 secant squared d theta. On the denominator, on the previous page, we already saw that x minus 2 squared plus radical 2 squared. Well, that's just using the Pythagorean identities. We had 2 secant squared, but this time this is also squared. So it looks like here, because this denominator, this is 4 secants to the 4th. So we could cross off 2 of the secants, but not all of them. And we could also perhaps split this, distribute this root 2 to both terms. So here, let me rewrite this as integral so technically let me not write this secant because we already canceled. I just have a tan. And then we have 4 secant squared. We could cross off a 2 on the top and bottom over there. And then for the other integral, crossed off the secants already. So we just have 4 and then 2 more secants on the bottom. All right, so this is just distributing this root 2 and then breaking this into 2 integrals. And now let's evaluate each of these separately. So here, simplifying these integrals, we have 1/2 tan theta cosine squared theta for the first integral. And for the second integral, just rewriting that as cosine squared theta d theta. I'm running out of room here. Let me go on to the next page. Well, simplifying from the previous equation, we have 1/2 sine theta cosine theta. That's the first integral. And then using the half angle identity for cosine, we can rewrite cosine squared is 1/2. That's where this 1/2 is coming from. 1 plus cosine 2 theta d theta. Now for the first integral over here, just use the u sub. So we have, let's go to a different color. 1/2 sine squared theta over 2 after you do the u substitution. And then we have 3 root 2. Combine that 4 and the 2 to get an 8 down there. And then taking the integral, we have theta plus sine 2 theta over 2. Now here, let's just rewrite this a little bit. Sine squared over 4. 3 root 2 over 8 theta. And then 3 root 2. And then here, also let me go ahead and rewrite this as 2 sine theta cosine theta using the double angle for sine. Those 2's will cancel. And after using that, I still have an 8, and then now sine theta cosine theta. So now I could go ahead and go back and rewrite everything in terms of x, but I'll need the triangle to do this. So we had x minus 2 equals root 2 tan theta. So we can go ahead and find the sides of this triangle. Use Pythagorean theorem to find the hypotenuse. And you could simplify it to look like this. So let's go on and use this. We could evaluate sine and cosine, and that's all we need here. And we've already found theta on the previous page when we did part A. So sine, we'll write those out, and then we'll go to the next page to write up the final answer. Here's theta, x minus 2 over the radical. And then cosine, adjacent over the radical. So four x down there plus 6. So let's go ahead and write out our final answer. First, we'll simplify b. We'll go ahead and replace this on the right-hand side with terms of x, and then we'll finally add a and b together. So b, that just becomes plugging in sine squared. And then we had over 4, that's where the 4 is coming from. And then when we square, the radical goes away. Just rewriting theta in terms of tan inverse here. We did that in part A. And we have 3 root 2 over 8. And then for cosine root 2, If you'd like, you can go ahead and take this and use long division here to rewrite this as 1/4. And then let's see here, we would have, after doing long division, we could write that. So the last step here is to just take our answers for part A, part B, and add them together. So that I'll write that here, and this will be the last step. So for A, we had √2/2, tan inverse. That was our theta. So that's just for part A there. And now for part B, so that first term we could have simplified if using long division. And then we have 2/4, so let's just say 1/2 x squared 4x plus 6 plus, and then we have 3√2/8. This is all from part B. And then we also have 3/4 x minus 2 x squared minus 4x plus 6. And then finally, we'll go ahead and add that c in. So this is our final answer, but this can be cleaned up a little bit. So the last step will be just simplification, and that'll be our final answer. So combining the tan inverses, we can write this. And then we also have 3x minus 8, 4, and then x squared, 4x plus 6, plus that constant c, and there it is. That's our final answer.